if I take the cosine curve, so y is equal to a cosine omega t. Just take a simple cosine curve here. What is the period? And it is time, so it is period. Frequency. It was written over here at one point. Might have been written over here. Written over here today. I'm talking about, once ago. 2 pi is definitely in there. All right, if omega is 1, what is the period? How long does it take for the cosine curve to repeat itself? Go with your last answer.
2 pi.
Yeah. All right.
2 pi.
2 pi, if omega is 1, it's 2 pi. If omega is not 1,
It's over whatever
Omega?
it is.
so 2 pi over omega is the period. Think about it this way, if I got, going back to the projection, if I got this thing spinning around like that, the angular frequency is basically the angular speed of that spinner, and the period is how long it takes to go all the way around. So the angle divided by the angular speed is equal to time. What's the relationship between period and frequency? Not angular frequency, but regular frequency. A huge impact on that part of 151. Units of period. SI units for period. What is period? Why am I using a T?
Time.
All right, it's time for what?
Seconds.
Okay, so units would be seconds, but what is the period as opposed to just normal time?
Along the cycle.
Yeah, it's the time per cycle, so seconds per cycle. Generally, we just write seconds, but I'm going for a point here. Frequency is how often something happens. So that would be the number of cycles per second.
Very.
How often does something happen within a certain amount of time? So the relationship between period and frequency?
They're versus, inverses, opposites. Yeah,
Multiplicative inverses or reciprocals.
that's the word.
So squeeze this in a different color here. So the period is 2 pi over omega, which is the same as 1 over the frequency. So the frequency is going to be equal, 2 pi times the frequency is equal to omega. In the US, the frequency of our cycles is 60 hertz. So omega is going to be 2 pi times 60 hertz. If someone would be kind enough. Units? S to the -1?
Yeah.
Yeah, generally it's not written that way, although mathematically you definitely make an argument for it. But usually if you just see seconds to the -1 or 1 over seconds, that's implied frequency and not angular frequency. And so it's generally you actually write out the radians per second, just so that it's clear that you're talking about angular frequency and not regular frequency. So therefore, omega is 376.99 radians per second times time plus, and it's impossible to know what the phase is, we're just gonna make it 0. And so apparently, we're gonna leave this as a cliffhanger for Thursday, when we reveal, will we actually do numbers on this thing. But this is roughly the amplitude of our current, roughly the amplitude of the voltage coming out of our outlets and the angular frequency. And in probably the most accurate lab of all of physics, you will actually figure that out. You will find an experiment. There's one part of that lab that if you're off by 1%, you've done something wrong. Yes?
When you think the value of 166, is this something, this is what
Yeah, the RMS value was that.
okay, so this is the RMS value, so the one over this.
That
is
generates.
where you get it. Oh, that's why I thought you were a Z. I was like, a Z from the last thing?
Yeah, that would mess things up.
So that makes that, which means that this is not, I've got the wrong concept here.
So the way you find the root mean square error or value is you take your function, you square it, take the average, then take the square root.
Okay,
That's the order in which you do things for the RMS value.
okay. And that's what just squaring it is this.
Yeah.
Right, okay, so.
Yeah.
Thank you. So that is just E squared, I just need to read